Hey, what's up everybody? This is Etho and welcome back to another episode of the Let's Play series. So, are you guys ready to get working on the villager trading system? Sound like a good plan? Sound like fun? Something you're looking forward to for the 4th episode in a row? Yeah, I think we should take a break from this. I have a general rule in this series. If anything takes longer than 3 episodes, we must take a break from it just for a bit of variation. A little bit of change is nice, right? But we will return to this, don't you worry. I had some people tell me this area looks a little bit dark, but it looks fine to me, right? I don't know. I keep my monitor pretty bright though, so maybe it's just me. But not to worry, everybody. I actually have a long list of projects I want to do, and included in this list are what I'm referring to as the Big 3. The Big 3 projects I wanted to do for a very long time in this game. Like, one of these was from even before shulker boxes came out, and I still haven't done it. The reason why haven't I done these projects if, I've wanted to do them for so long? Well, they are going to be massive in size and complexity, like think Nexus level kind of projects. They're going to take a lot of problem solving, a lot of planning, but the main reason I haven't done any of the 3 of these is because I actually thought all 3 of them were impossible. Like, I've spent hours in creative trying to work through the basic idea behind them, and I hit a snag, and it's like the more time I spent working on these projects, the more I realized, like, nope, there's no way to do it. Until just recently, actually, I took a stab at all 3 of these projects again, and for whatever reason, it just kind of clicked. I got through what was stumping me, and we can move forward with them, so we're gonna do it. I think because, like, new stuff has come out with redstone, new techniques. I'd like to think I got a little bit better at redstone in that time. And just a different perspective, right? You give time on a project, and you might think about it differently the next time. But yeah, we got what was stumping me figured out. That doesn't mean I'm not going to get stumped again on something else, but like the main thing holding us back has been figured out. So we're just going to focus on one of these big projects first, the big one, as you might say. I've always wanted to build a computer in Minecraft. Now, not the traditional sense of a computer, like you might have seen like 200 block glowstone screens and millions of redstone, and it runs at 1 hertz every millennium kind of computer. I'm thinking more like a practical, like what works in Minecraft kind of computer. It might not even compute. It might just collect and show information. It is kind of what I'm aiming for. I want it to be a bit more of a fun thing. So the thing that was really stumping me on this idea was the display. I wanted to get it so we could represent 1 pixel with 1 block. If you've seen other like redstone display things, usually the way they do it is they do a 2x2 for each pixel, just because of the space limitation. That was what was getting me. Yeah, so I'm going to try my best here to walk you guys through the problem solving with me so we can all enjoy the journey of the suffering that's about to come. But let's say we want to control 1 pixel on the screen here. We can't just have like a repeater right next to glowstone because that'll light up 5 of them. You need a block spacer, and then it'll only light up 1 of them, okay? So that's the first thing to keep in mind. Now, what if we want to light up the pixel next to this one? Well, we can do pretty much the same thing, right? Just get a repeater over there, and then maybe we add some redstone here, and uh-oh, these 2 have merged together. So we have to be careful. If we want to control each pixel individually, we can never allow them to merge together like this. There is a trick in redstone, though. If you're tight on space, you can usually just extend things out further and take up more space. So if we do something like this, they're still separate. We can control the 2 pixels individually. All is good. What happens if we want to control the one above that, though? Oh, boy. We kind of need to put the repeater right on top of this one, right? And that's just not possible. There is a limitation in the game how tight something can be. And this will not work. So you need to come up with a new technique. And you might think, all right, Etho, not a problem. Just do something with pistons. Pistons are great. Pistons are amazing. You can do all kinds of cool things with them, right? Yeah, they are cool, but not for something like this. If you imagine having like a big wall of pistons to light up your pixels, you are going to encounter a nightmare of bud powering and things not behaving the way you want them to. And just no, let's stay away from pistons, okay? I've tried them. They don't work no matter how clever you seem to want to get with them. And we can't really put anything on this side of the screen because this is the side we need to see, right? Anything we put on this side will block our vision of the screen. So you really only have one face of the block to work with. So funny enough, I did actually find a solution to our problem here. It's just not a really good solution. Observers. Observers are cool because they don't really interfere with the other observers next to them. They just, you update one side of them and then they can send that signal through without interfering with any of the other ones. So that's really cool. But you'll notice that lamp just comes on for a split second whenever we send it a pulse. It can't hold a pulse, which is the main flaw with them. So if we want to keep a pixel lit up, what we actually need to do is have a clock. So when you have one observer facing another one like that, they automatically create a clock. So if we send that through, they're rapidly updating each other to keep the signal going, and it stays on. And then if you staircase the observers, so like if we make the bottom row the longest, and then we go in two blocks all the way up, you get like a half pyramid that would work. The bottom would have a longer delay though than the top part of the screen. But look at this, like we can update each pixel individually if we spread it out enough. So that would work, right? But if we turn on like 100 pixels on our screen, that's 100 clocks running in the game. So I didn't say it was a good solution. I said it was a goofy one, right? Not the best, but it is functional. Aha. You think we're really gonna settle on some goofy display that legs my game out just because we were able to get it down to a 1x1? Nope. This is Minecraft we're playing here. This is all about being creative, reaching new bounds, new lands that have never been discovered in Redstone, or something like that. Yeah, we're aiming a little bit higher. Yeah, so our true goal with this project is way more fun. We're trying to make 1x1 pixel display that's also 16 colors, and it must be fully resettable. That's what we're aiming for. Let's begin. So, if you're gonna make a color display in this game, what is special about a display? What makes it a display? It changes, right? You can turn the lamps on and off. They change. What else changes in this game that is also in color? Concrete powder. So concrete powder can move, right? Movement is a form of change. So we can change the screen by moving the color around. That's a possibility. We have one other possibility as well. Well, there might be more, but I could only think of two things. We can also use shulker boxes. Shulker boxes can be broken, they can be placed, they can be dyed different colors. This is what we're actually going to use for our display, just because I think it'll be a little bit more versatile, a little bit easier to work with than this. This is going to be really hard to reset, while I think this will be a lot easier. It's a little bit of a balancing act because they both have their pros and cons. Like shulker boxes, for example, have a render distance limit. So if we want to see our display from a long ways away, shulker boxes are not the way to go. This is a limit here before they render out, right? So that's where concrete powder beats shulker boxes, but I don't plan on having our display that far away. So instead of having a wall of lamps, our color display is going to use a wall of dispensers, and we're going to use these to place our pixels. So if there's a shulker box in the dispenser, we send it power, then it can eject it, just like that. And that works out all nice and fine, right? If there's another one in there and we activate it again, nothing happens. It just stays inside, okay? Here's the fun thing though. Now, if we're gonna do a color display like this, guess what we need to do? We only had that one side available, right? And now we need to use that side on the back here to actually get our shulker boxes into the dispenser. We're gonna have like a bunch of hoppers behind the wall. And that leaves us with 0 sides left for placing and picking up the shulker boxes. This is where we start cheating. So this gets really tricky because we somehow need to activate all of these dispensers with redstone. We also need a system for collecting the shulker boxes for when we want to switch to the next screen we're rendering. We have to break them and pick them up somehow. And we're not allowed to put anything in front of our display that will block our view of it, right? Oh boy. Well, there is a solution actually. It's called a flying machine. So that will temporarily block our view of the display, but it's not a big deal, right? Is this going to whiz by? It's almost like a scan line happening on our display. I don't know who invented this. It wasn't me though, so sorry. I would give credit if I could, but we're gonna definitely be using it because it's really cool. Oh, I missed. There's a button up there. Oh dear. There we go. And it's a two-way flying machine, so it'll go up and it'll go down. Very cool. So we're going to take advantage of the fact when you move an observer, look at the dot here, it activates whenever it gets moved. So that'll send power. So all we got to do with this is stick an observer onto our flying machine that faces towards the dispensers. And when it goes up and when it goes down, it will activate them on the way. And I got a little test example done here. We have a red and a purple shulker box in just the one column all the way up. All the way up there. So let's see if it'll place them on the way up. Oh, interesting. Okay, wasn't quite expecting that. So it activated twice. That's not good. I was really hoping for a single activation there. Okay, I gotta think about it, but it did do what we wanted, kind of. Well, maybe before I start really scratching my head here, let's just do one more test. I only have one shulker in the dispenser, so it should clear. We're gonna see if it clears the column there, and if it places the next one and then also breaks the next one, or if it's gonna leave a column behind. So let's just get this thing going down. We want it to leave a column behind when it goes down here. Oh, it is. Oh, so maybe the problem is because I had two in. Yeah, okay, that's perfect. That's perfect. That's exactly what we wanted to see. I'm going to test it one more time going up. Okay, so same deal here. We just have one shulker box loaded all the way up, just in the one column, not in the ones beside it or anything. Not yet, anyway. Let's just make sure this works. So we want it to break the column that's there and then place the one that's inside the dispensers. And it's breaking and replacing and leaving the column behind. Okay, very good. Very good, very good. So then if there's nothing in the dispensers and it goes down again, I gotta work on my aim. Really embarrassing when you're recording and you can't hit anything. There we go. It should just clear it because there's nothing left to place there. There's nothing in the dispensers now. Cool. Okay, so that handles the height of our screen, no problem, but we still got to worry about the width of our screen. How are we going to do that? Well, obviously, we need more than a 1 wide pixel screen here. We're actually going to be aiming for 27 pixels wide by 11 pixels tall for a grand total of 297 pixel resolution for our screen, which I think is a decent size to aim for. Got to remember I'm playing this in survival, so it can't go too crazy here. This is already a little too crazy. 27 wide, though, is from that column to that one there. And 11 tall is what we got. That's 11 dispensers tall already. So it should be a fair size. That will allow us to display 7 characters on 2 lines. 14 characters total. If we do 3 wide characters, 5 tall, you can represent pretty much any number and letter in the alphabet that way. And leave a 1 block gap for a space between the letters. And yeah, should be good. We can also display pictures on our screen too, though. But in order to make our screen wider, we need to make our scan line thing wider. So to do that, all we have to do is extend this. We can get up to 5 blocks wide for each of these flying machines before we hit the piston limit, which is 12 blocks, right? But that will operate no problem. You can hear it's a lot louder now. If you guys have watched my series for a while, you've probably noticed I don't do a lot with flying machines. I probably should. Like, they're really cool, right? But to be honest, they scare me a little bit. They're not quite as scary as they used to be now that we have observers, but still, I don't know a lot about them, right? So I'm going to make an effort to learn them in the future here. But I went and I set this up, and when I went to activate it, I always thought you could use the slime blocks and honey blocks interchangeably, like it didn't matter. And I got a little bit of a surprise. All the honey ones got left behind. And we have to use both honey and slime blocks so they don't stick together. And I was like, what? And then I went over here and I did a little test, and it's like, oh yeah, honey doesn't send a signal through because it's not a full block, right? So they behave differently, and you can't just interchange them, right? So I went and I looked online on YouTube, and I found a tutorial by iMindCrazy. I'm not sure if he's the inventor of this. I don't know. But anyways, it's a two-way flying machine that uses honey blocks. That's exactly what we need. It's a little bit more chunky, but it's fine. So I think we can just hook up like we need here. Ooh, we want it to go 5 blocks wide, ideally. Get our observers on that. And let's see if it still flies. Yeah. And down. Yeah. Cool. Oh, snappers. All right, everybody. This is a little bit later now. I've been tinkering with the flying machines, and I didn't realize it at first. This flying machine is actually incredible for us. It solves so many of our problems that were about to come up. And now I don't have to worry about them. We got them fixed already. It's so good. So I've been studying this thing, and if you look at it, the observer goes directly into this sticky piston, which pushes the honey up, right? This observer goes directly into this sticky piston, which pushes the slime down. You'll notice none of the observers go into the slime or the honey, which means that whole issue where honey doesn't send power through isn't a problem for us. And also, it doesn't bud power the pistons in any way. So it's very simple. And that means we can actually swap, like where the slime is here, with honey, and vice versa. Honey can become slime. And that's great in our application here because we need to swap them so they don't stick together. And that means we can use the exact same flying machine for the task here. Which is good because we were going to hit a problem where we had to synchronize the scan line going up. If any of them were out of sync by even 1 game tick, it would probably cause funny things to happen with activating the dispensers. But look how perfectly straight that is. They all activate at the same time, and they should update the screen all at the same time. So that's cool. It can go up and it can go down perfectly in sync. But the other big thing, and that causes a lot of lighting updates, I didn't realize, but now that it's getting dark, it's like, oh, wow. The other cool thing, though, is it's flat on top, okay? So you got to imagine after we clear our screen, stuff might land on top of this thing, and we have to get it off somehow. And with the old flying machine that was all jagged and stuff, it's like, how are you going to clean all our pixels off of that? There's going to be hundreds of them, right? If it's flat, all we got to do is like send some water on top, and it'll rinse it off, no problem. Send all the items to a water stream somewhere, and it's easy peasy. That was going to be a problem I had no idea how to solve, and it was coming up, and now I don't have to worry about it. So I'm very happy about that. Oh, you have no idea. But before we jump ahead here, let's do a little test just to make sure everything's working correctly. It's very important when you're doing redstone, test it thoroughly. I usually don't test it thoroughly enough, and I find problems later on. And you usually build off of a stage to the next stage and then on to the next one. And if you have a problem on the first stage of your build that you discover later, it affects every single stage that you've connected to it, right? So it's good to just do a lot of testing as you're building to make sure you don't have problems you'll discover later that will require a complete redesign, right? So in our test here, we're making sure it works horizontally. We haven't really tested that. We just did the column test, right? But we're also doing this on a line between 2 of the flying machines, because you got to remember, like, this flying machine, when it goes up, it actually affects 1 block over on the left of it. And likewise, this one will affect 1 block over onto the right of it. And that might cause issues unless they're in sync with each other. Then I'm hoping they will block the dispenser from ejecting the shulker at the incorrect time, you know? Okay, let's give it a go here. So this should swap from red to purple and vice versa. Yeah. Good. Boy, those pixels are flying. We still might have some issues with collecting our pixels after, but hopefully it won't be that big of a problem. Because they will end up here, I guess, right? Yeah. We can probably rinse them up here, though, right? All right, awesome. So I think we got the main functionality of our screen figured out here. I think we're good to move on to some of the nitty-gritty details of how it's actually going to work. It's kind of important as well. So this is like a combo problem. We got the mechanics of our screen, right? So with the flying machines and stuff, but there's also data management is a huge part of this whole problem. So we're trying to avoid doing anything in binary. Binary is the plague to us. Now, if you think about it, our screen is 27 by 11. That's 297 pixels. And we're doing it in 16 colors. So that greatly amplifies the amount of information we need to store to represent a screen. So you need at least 4 bits of information in binary to represent 16 possible combinations. That's a total of 1,188 bits of information per screen. I don't know how to represent a bit in less than 3 blocks in this game, so you can imagine the size that you would need to do that, right? So it gets crazy. While if we are a little bit more clever about this and we just use the Minecraft mechanics of, like, let's keep our information as shulker boxes, pixels, that we can move around and stuff, we can represent our screen just by filling up some double chests of shulker boxes and keeping the correct order of our pixels. So each double chest holds 56 pixels. We would only need like 6 of them to represent a full screen, and that's like no space whatsoever, and it's very easy to access our information that way, right? Aha! And the really cool thing about this, because we're using shulker boxes as our pixels, we also have the ability to store extra information inside our pixels, inside the shulker boxes. So you can imagine when we clear the screen here, the pixels aren't going to be in any kind of order. They're going to be a big jumbled mess. We have to run them through garbage collection, figure out what pixel is what, and then send them back into some kind of pixel storage. So the white pixels go into a white storage area. The black ones go into a black storage area. We got to separate them. We can actually distinguish between our pixel colors by putting items inside our shulker boxes. So we might have 0 items in our black ones. Like we'll assign a number to each of our colors. So black will be 0, gray will be 1, light gray will be 2, white will be 3. And then when we run it through a pixel detection system, so like it doesn't know what order it's going to get these, right? But when we send it to a comparator, oh, we can see number 1 with redstone, we can figure out that is the color gray. And then we unlock the gray hopper in our pixel storage and we send it on into that, right? And we do the next one. No, it didn't light up at all, so that must be black. Send it to the black storage. White goes into white storage, right? And so on and so forth. We can reclaim our pixels that way and use them again in the future when we need them. All right, here we go. So this is either a good idea or a bad idea. I'm not sure yet. It's either going to clarify things for you or confuse you even more. But I tried to create a mock-up of like the 5 main systems we need and how they will interact with each other. So I'll try run you through this and hopefully it helps. So we got our pixel display represented by this here. We worked on that today, and hopefully that was fairly clear. After the redstone here is going to show like where the pixels are going in our system. So after we clear the screen, those pixels are going to follow the redstone here, boop 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 boop, all the way over here to garbage collection and pixel storage. So we're going to have a big warehouse, not warehouse, but like a bunch of chests of all our different pixels. All 16 colors, probably at least 500 to 1,000 if I was to guess, shulker boxes of each color, so it's gonna take a lot of resources in the end of things. Okay, pixel storage, where do we go from there? We can send pixels to our CPU, and then it's gonna arrange them for us and create screen renders. So just to give you an example of something the CPU might do, you know how you can have like letters on banners? We could maybe make a CPU system where we chuck it different letters in banner form, and then it processes those into actually rendering those letters onto the screen, right? It's in charge of ordering things. Okay? Once it's done its screen render, it sends it over to RAM. So much like how your video card has RAM, this basically stores different screen renders. It'll probably save at least 5 to 10 different screens. And that's basically just a double chess system. That's all this is going to be. Okay? As you saw with our screen there, it actually destroys the image when we're done with it, right? We might want to save some of our images, so that's why we want to have RAM. If we just sent stuff directly to our screen, we could only see it once and then it's gone. But if we send it to RAM, we can then send it to a pixel copier, okay? So it'll create a copy of the image, depending on which one we select from RAM. It'll create that copy, and then once it's done the copy, it'll send the original back to RAM. The copy then gets sent to the screen, and that's what gets displayed over there, okay? And if we ever want to clear RAM, like get rid of an image saved in RAM, then that goes also to the pixel storage and garbage collection system. And that's basically it, everybody. All right, so now that we covered that, we can get back to our screen here. So the CPU is going to order our pixels, right? It'll do it for us. Or we can manually arrange stuff in the chest ourselves. That sounds painful, though. Like, to do it for an entire image is going to take some time. But I might do a few image renders that way, especially when we're testing things. Anyways, my point is, all our pixels will be in order when we send them to the screen. So all we really got to do with our screen is try to get 1 pixel in each of the dispensers. That's the next job here. Which looks a little difficult, right? It's actually pretty simple. The trick we're going to do, if you put a shulker box in the top of the hoppers here, they will flow down to the very bottom one and end up in that one, right? Now, if we lock the bottom hopper, we do it again, it'll flow down. It can't go into this one, though, anymore because it's locked. So it'll go into this one up, right? So if we can lock the hoppers from the bottom up as we send it the information, it'll distribute it throughout the entire column. We're going to do that using pistons. Now, there's something to keep in mind, though. Like, we're going to have a piston tape is what we're doing. If you have a redstone block above a sticky piston, go up. Go up for the people, please. There you go. Yeah. It will not retract afterwards because this redstone block is powering the piston still. So in order to push up our redstone block here to lock our hoppers, we're going to have to add an in-between block. And then it should be able to retract after that. So if we send it like that, and then we remove it, it's able to move the block there. This is the part where I start sweating a little bit. You know, that number 11 for the screen height, that's a good number. You know, it's a nice number. If you have 5 tall characters, you can have 2 rows of characters in an in-between space, right? But the number 11 is also pretty close to the piston limit, especially when you add in that in-between block. Does it push up here? Oh, thank goodness. Okay, so it is possible at least. I don't think we can go one more than that though. No, we've hit the limit there. Okay, so that's the piston limit, right to the very top of our hoppers. Which means we can't just have another piston on top of the hopper that are pushing to the right or anything like that. What we're gonna need to do, let's go up. Let's go up. Fly, fly, fly away. We need to pull this block back. We're going to have a sticky piston to pull it right there, I think. So it'll pull our piston tape over. And then we'll have another piston, a regular one, right here, I think. Hopefully this works out. All right, so we got a rough example of our piston tape rigged up here just so we can test it out, get an idea for it. And it's looking good so far. So the idea is we're going to take our image, send it to our screen. That's going to happen by, there's going to be 27 hoppers running along the length of the screen, which will fill up with pixels. Once it gets to the 27th hopper, we're going to unlock briefly, just for a moment, another row of hoppers below that, which will pull the pixels down into the screen, and then it can start receiving more. Those pixels will flow down one row down to the very bottom of our screen until it hits locked hoppers, okay? I moved this all down by one block because I realized the starting position of our redstone block actually needs to be here, not up here, because we need to send our first pixels into this row, right? So we unlock the hoppers up there, it pulls our pixels down, and then they get to the bottom. We iterate by one, and now the next set of pixels will go into this row of our screen, right? We do it again, it goes up one higher, and we just do that 11 times until our entire screen fills up and we run out of pixels in our image, and we're good to go. We're ready to activate our flying machine then. So we don't need to go to the very top either. That's the top over there, because that hopper will be locked, so then it'll flow into the one above it. So the other important thing is we got to make sure our piston tape is exactly 11 blocks on each side, 22 total, so that when we're done, when we go there, we have fully reset and we're ready to go again. Well, anyway, everybody, that's probably as far as we'll get on that project today. The next step, I would say, is to figure out exactly where we're going to be building it. We were just kind of testing it out there. Nice open area, but we need to figure out exactly where it's going to go. Probably that new area we're working on somewhere. But we need to know for sure, because once we convert the shulker shells into shulker boxes for our pixels, that's it. We're committed to that spot, because I'm not moving like 36 shulker boxes at a time every trip. You know, once they're crafted, and if there's like 16,000 of them, you know, that's it. You're stuck in that spot with the project. So that's what we got to figure out next. It'll probably be a while before we figure that out, because we got to work on that new area. But anyways, we'll get back to that eventually. What we're going to do now is get to the comment of the day, which says, "Hey, Etho, what do you want to see in future Minecraft updates? The everlasting inventory issues has always been a thing. Would you like to see craftable backpack, or should it be something you'll need to explore for? I.e., it's not something they should make available with trading, since the game is already broken in that regard." Yeah, so obviously inventory updates kind of needed at this point. I don't think backpacks are necessarily the solution everybody's looking for. We kind of have backpacks already. They're called shulker boxes. I can tell you from experience playing modded Minecraft, backpacks don't solve everything. It's nice to have that extra inventory space. Yes, that's true. But you still got to clean them out eventually, right? They fill up, and then you have tons of backpacks that need to be organized and stuff. Yeah, anyways. What I would actually like to see from Minecraft updates, so I kind of got two answers besides the inventory thing. Like, I think the proper thing for them to do is, like, every update adds some new blocks for the builders, add some new redstone stuff for the redstoners, add something for the adventurers to go look for, you know, try to get something that appeals to everybody. A little bit of everything is nice. I love when they can do that in updates. What I actually want them to work on personally is the stuff that's complicated, like the key systems to the game. I think a good example of that is how they recently did the whole world height change and redid the whole underground terrain and stuff. That's a massive thing that you can't really do in modded. Like, they need to do that kind of stuff. So I want them working on that. But like extra blocks and mobs and stuff, you can get that through modded Minecraft. Probably better than Mojang will ever do. So that's not where I'm personally interested in them working on the game. What I would like to see them do is add more movement to the game. More things like NPCs would be great, so that you can tell stories through NPCs. stuff like the create mod that you can move more stuff in the world and make it more interactive. I think that's where I would like their focus to go. Make key systems around that, similar to the create mod and like the NPC mods and stuff. That would bring a lot of life to the game, I think. I'm losing my voice. Hopefully you guys enjoyed today's episode. I had a lot of fun doing this, and I'll see you again in the next one. Take care. Have a good day. Bye-bye.